Hello, welcome back, and this lesson is to build on the previous lesson of the same name, geometric sequences, but this one is part 2, where we're going to look at some more problems with geometric sequences, and let's get started. So a quick review, here's the formula for finding the nth term of a geometric sequence, and we're going to go ahead and continue to use this same formula, but what we'll do is we'll tackle problems where they give us different challenges, perhaps to find the first term or the nth term or something like that. And so we'll just be learning how to manipulate this formula a little bit more deeply. So here's our first example. We have this geometric sequence. We know that the second term is -6 and the fifth term is 162. Find the general term of the sequence. That's the same thing as asking find a formula for the nth term. So we should make use of the nth term formula. As you dig into this, I think you're going to realize that this question is a lot harder than it looks. But you might want to pause and see if you can't work your way through it, and then come back to this video and see how well you've done. Okay. So we go ahead and write what we know. We know the second term is -6, the fifth term is 162. We don't know what the common ratio is, and we don't know what the first term is. So it looks like we're stuck. Let's go ahead and use our formula though. That's always a good idea to go to that formula, because that's the main tool that we have to tackle this question. And we can substitute our values in. And quickly, we run into a roadblock. So here's our fifth term. We know is 162. We don't know either of those. We just know that the exponent is going to be to the fourth power, and then the same thing here for the second term. And it looks like we're stuck. But hopefully you realize from your algebra background that you have two separate equations. So equation 1, equation 2 here, and two unknowns. And so you should be able to combine those two equations simultaneously to find out a solution for both u1 and r, and that's what we're going to do. In this particular example, the way we're going to do it is we're going to take the top equation and divide it by the bottom one. Now I arranged them purposely so that the larger one was on top and the smaller one was on the bottom, just so that we don't have to deal with fractions as much. So I take 162 divided by -6, and I'm going to set that equal to this term divided by this term. And what that's going to do for me is I'm going to get a number here on the left side, but the u1s are going to cancel out. And so all that I have left on the right hand side is r to the third power. And then what we can do is we can take the cube root of both sides. You are allowed to take the cube root of a negative number here, because -3 times -3 times -3 is -27. So we find out that r is equal to -3. We can't stop there though. We have to now know what the first term is. So we can take either one of these equations, this one or this one, and substitute what we know r to be to figure out what u1 is. So I've taken this second one. The numbers look nicer. So I've taken this second one, substituted in for r, and now I've solved for u1. So now I have the first term and the common ratio, so I should be able to write a general term now. And so, oh, that didn't work out. Anyway, so the general term is the nth term. So we write a formula for the nth term. Here's our first term is 2, common ratio, and to the n-1 power. So that would be the final answer for that question. Now I put this in here because I want to make an important note that these two equations are not the same, right? You need to have the brackets around the -3 when you take the exponent, because what this is reading is I'm going to take 2 and then I'm going to subtract the answer that I get for 3 to the n-1 power, as opposed to I'm going to take 2 and I'm going to multiply that times -3 to the n-1 power. So make sure that you are using parentheses that you're typing it in correctly. Okay, so let's take a look at the next example. Is this series geometric? Well, we're multiplying by square root of 2 to get from one term to the next, and we're doing that throughout the sequence. So yes, this is a geometric sequence where the common ratio is the square root of 2. Now the challenge is, how do we find the very first term that exceeds or is bigger than 1,400? So we see that the size of each term is growing and growing. What number term do we have to get to for that to be a 1400? Go ahead and press pause and see if you can figure that out on your own. Okay, so again, you could do that by brute force and just keep on multiplying by square root of 2 until you get a number that's bigger than 1400 and count all those terms to see which term that is. I'd like you to use the formula though. So we identify the first term as 6. The common ratio we identified as square root of 2. We don't know which term is going to be bigger than 1400. So let's substitute this into our formula. And so we should have this. So what number term would give us a value that's bigger than 1400? Right. And if you have the algebra skills to do this, then you can continue to use algebra. You'd use logarithms to be able to solve this question. If you don't know logarithms, then what you'll have to do is you'll have to go to your graphing calculator. And so that's what I'll show you on the next slide, is how to use your graphing calculator to solve this question. What you'll have to do is you'll have to take each side of the equation and go into your graphing calculator in the graphing portion of it, and you're going to assign y1. On this particular one, what you can do is just type in the right side of our equation. So here was our inequality, and what we're going to do is we're going to type this portion of it in to y1, and then what we can do is we can go to the table, and then you can just arrow down until you see when the number gets bigger than 1,400. So I can see between 16 and 17, somewhere in there, it gets bigger than 1,400. So the 17th term is the first term where I get a value that's greater than 1,400. Okay? And the other way that you could do this is you could type this in as y1, and then you could type this in as y2, graph both of them, and find the intersection point. That'll give you the n, the exact n value. So it looks like n would be somewhere between 16 and 17, so maybe like 16.4 or something like that. And then we know that the next whole number bigger than that would be 17. That would give us our answer. So you could do that either way. Okay, so here's the algebraic solution. So here is the equation, and if we wanted to go ahead and continue to do algebra to find the answer, what we could do from here is divide both sides by 6, and then I can use my exponent rules to simplify this side, so it's 2 to this power. And then what I can do is take the log base 2 of both sides. And what that's going to do is that it's going to get rid of this 2 right here, so that we just have the exponent. And then we take the log base 2 of the left side. We can multiply both sides by 2 and then add 1. Type this into our calculator. We get that n is got to be bigger than 16.7, I guess 16.4. But all right, so 16.7. So any term bigger than that point, so the 17th term would be the first term that would give us the correct answer. So that's it. Those are 2 more problems using geometric sequences and your graphing calculator to solve. Hopefully you found this helpful.